Hi, my name is Nikki Seward. It's June 28th, 2014, and this is a short video showing a 3D model and the actual depths of the waterway and the obstruction that is at the north end of Steamboat Slough. The obstruction does not hinder boating, it doesn't hinder recreation boating, but what it does do is modify inflow into Steamboat Slough, and also probably has had an impact on the last couple of years of salmon migration studies. And I'm going to show you a little bit of this model, and then I'm going to go through the history of this actually. Now this graphic 3D model was based on data provided by Paul Marshall from DWR just about a week ago. And what you're looking at right now, there's Sutter Slough. This is Sutter Island, Grand Island. There's a deep hole. The bridge, the Steamboat Slough Bridge, would be right here. There is, in the water, it looks like it's above ground, but it's not. It's just the coloring of the graphics he originally provided to us. There is, like this area is 10 feet deep and 8 feet deep, and there's this a little bit deeper channel. And so I'm going to go through the details of it so we're going to be able to kind of go through this whole model. But so you can see it, I'm going through right now, so you can see what happens when you're on the Sacramento River. And the water, a lot of the flow gets blocked and goes around this way on down the Sacramento River. I want to take a look at the history of this. So I think I have to resize. This is information, it's a PDF. You can get it at snugharbor.net and go to the barriers pages, or my news page from Snug Harbor, and there's a timeline to all of this. You need to know that Steamboat Slough is the original waterway the steamboats went up to. This is a timeline from 1850 all the way to 2014, and we look at exactly when this obstruction, and I call it an obstruction because, let's see if you can read this. I don't know if you can. I had been challenging DWR and Mr. Paul Marshall from DWR because I knew that there was already some sort of barrier or obstruction at the north end of Steamboat Slough. It shows when you go by in a fishing boat and you can see from sonar. Anyway, Mr. Marshall did finally admit it only in June 17th. Hundreds of people from the Delta remember the meeting we had in Walnut Grove. Interesting that they never admitted that there was already a obstruction along Steamboat Slough that was affecting water flow. He says he has an answer. This is from Mr. Marshall. I'll just read it. I do have an answer for you on the obstruction at the head of Steamboat Slough. The underwater berm you speak about is actually a naturally occurring shoal. And then he provided me with slides. Well, I'm going to go through this series of slides and the barythric data and show you it's not a naturally occurring. I have photos of the rocks and everything. For reference, here's Steamboat Slough Bridge. This is the rough location. This is the north end of the bridge attached to Sutter Island. Here's another photo of the beach area. That was a 2011 photo. If you want to go through this, you can see the history of Steamboat Slough. Here's some of the data provided. This is the 2000 bathymetry from Mr. Marshall, and they gave me a 2008, and here is 2008, and it shows that something happened right here. It actually turns out it appears to be either a solid wall and then a pile of rocks, and you will see that we knew there was a wall there. And then this is going to 2014. That was used to make the 3D model. And just for reference, if you're on a boat, you can see that it's a very steep. It goes from about 10 feet deep in this area. Well, sorry, Sacramento River is 19 to 21 feet. There's a shoal building because of what was put in the water here. And so it is still 10 feet deep, and this area is about 8 feet deep and getting more shallow. So there's actually two different shoals going on, and the structure inside the shoals, you can see on this one, that indicates a solid wall of cement or metal or something. That is not a naturally occurring. You can see the sheerness of the wall indicates it is not naturally occurring. A normal river bottom would have 1 to 2 foot little ripples like that, not the sheer walls that we're seeing. It's important to note this stuff because the computer modeling for the Bay Delta Conservation Plan, DSM-2, and a couple others, they assume this averaged channel. This is one of their side profiles. Clearly none of the channel is that way, and they did not seem to be aware of the changes to Steamboat Slough sometime after 2008. Here's one of the graphics taken from the 3D model that I'm going to take you through. So you can see there's rocks, and then there's a shoal. There is this little very thin channel, and it actually has rocks in it. And then a very deep hole that kind of has a flat bottom, and it's a very steep wall against here that needs, the Grand Island Reclamation District should pay attention to that. That's another view we're going to go through. So I have a lot of questions about how did this happen, but I wanted to bring your attention to something. This is a 2007 graphic from a presentation by Metropolitan Water District. And they're the ones who proposed, actually, I think around 2004, emergency freshwater pathway concept, where they put these barriers in. I have the feeling if we went looking, I know that I've been on Sutter, Steamboat, Georgiana. Right below Georgiana on the Sacramento River, there's like an in-water berm as well. There seem to be diverting water into Steamboat Slough, into Sutter Slough, and diverting it away from Steamboat Slough. I think this has been going on for at least a couple years. And so I'm going to go for reference. This is Metropolitan Water District of Southern California. And they're the ones who've been really leading the science, the CalFed science. And they have different names for the Echo Crescent Middle River Conveyance. They have those South Delta barriers. They talk about doing the siphon and going under the river to get the water going to export pumps. So there's that emergency freshwater pathway concept. There's the ones who are the dual conveyance. All the language that we see in the Bay Delta Conservation Plan now that they had inserted in the CalFed. The raised canal profiles, that's about elevating the canal levels by silting them in so that there's less water needed to keep those canals fresh so that there's more water to export. That was that concept. So let's go on to something else. So if you wanted to learn a whole bunch about this, I gathered a bunch of the documents along with putting up that time frame. And you can click on these to see larger versions of each of them. I included some of the emails back and forth. I included the conceptual model from when they were first trying to figure out why the salmon go one way or the other. And one of my, I believe that one of the reasons they manipulated and created a barrier or obstruction on Steamboat Slough is that, you know what, I need to refresh that page. I'm going to refresh it because there's actually some other pictures on there that didn't seem to show. There we go. There's rocks at the bottom. Just yesterday I was out there. I had to go gather. There's actually seems to be a little cement wall along one ridge. And this is the Steamboat Slough Bridge, Grand Island right over there. And I just wanted to bring all of this to your attention because, okay, now I'm going to enlarge it so we can go through that one. So I am going to go through this so you can understand. I'm not very good at this. never done video games, so I'm just kind of learning these kind of things. So if we were on a boat, I'm going to back out. So here's Sutter Island, that's Grand Island, and we're going to go into Steamboat Slough. It's actually a more smooth sheer walls, and this is still water. The most shallow it gets at mid tide, and that's not a hole really there. That is representative of rock or something more solid than the sand. It's still 8 to 10 feet deep here, and same thing here. But to any fish swimming, they're going to probably go for this more shallow area that has the rocks and go through. So I'm going to spin around so you can see. Sorry, this might make you seasick. Spin it out again from sort of where we started. There's Sutter Island, Grand Island. The other thing I wanted to look at is this very deep hole. It is 35 feet deep in this area and very flat on the bottom. And it kind of doesn't make sense. Why is that hole there? It has been developing. The walls along here are very sheer. I would think this would be very concerning in this area for the reclamation district. The bridge kind of reflects right along here, and the hole is deepest right in this area, basically almost under the bridge. It was actually really fun looking at things in the underwater camera. So again, this is based on the data provided. It was flat sheet data provided by Mr. Marshall from DWR, which was then created into a 3D model. So it's actually a smoother walls, but you can see that goes down the Sacramento River and then gets into these small channels. So this is definitely blocking freshwater flow into Steamboat Slough already, even though it does not block recreation boating at all. This is still 8 feet deep. This is still 10 feet deep. What created this? And it was sometime around 2008. Maybe the rocks and a solid barrier were put in, and thereafter they've been experimenting, and that's what Mr. Marshall means by naturally occurring. But the original rocks and steep barrier that we show from the sonar, that part was not naturally occurring. That was definitely man-made. So if you have any questions, the best place to go to, all the links for everything, is at this Snug Harbor. I'm going to end with snugharbor.net, Sacramento River Barrier HTML. And if you want to know more about this is going to have the links and the timeline and everything. Thank you for listening. Bye bye.